So in this section, we're looking at the order of operations with integers. It is important to remember that we use PEMDAS, right, in with whole numbers and so on and so forth. But even with integers, those principles remain. And so right away in the section from the Redwood's pre-algebra book, it talks about the rules that guide order of operations. Again, we have parentheses first and then exponents. Then multiplications and divisions are done in the order that they appear from left to right. That's important to remember. And then we do the same for addition and subtraction. So parentheses get the first position, and then we get second goes to exponents, and then we have multiplication and division. They basically rank the same, and the one that wins is the one that occurs first from left to right. And the same thing goes with addition and subtraction. So from left to right, that's how they work, the same way there. So they'll get the fourth position, or if you want to be technical, you could say they get the fifth, since multiplication and division are both tied for third. But you get the idea there. So I'm going to just work and do the problems that are presented to you, similar problems to the ones that are presented to you all through this section. So let's start right away from the first example. And so we're going to look at an example right away. And this example has to do with a situation where you're asked like -4 squared or versus -4 squared. Well, -4 squared with the parentheses here, right away we know that that's the same thing as saying -4 times -4. And that is actually a positive 16. That's the way it works there. However, in this case, it's different. It's different because this negative is actually its own thing, right, apart from the 4. And so this squared applies to the 4. So that's essentially like a 4 times 4. And we know that's 16. But that negative is still waiting out there. And so for that one, it's going to be -16. For the one on the left, it's -16. And the one on the right is 16. Now, please keep in mind that if you are doing this section and you feel like some of the arithmetic is getting intense and you want to come back, that's okay. So when you do the first 4 sections of chapter 2, you've received a solid foundation. And if you want to go do the first 4 sections of chapter 3 and so on, that's fine. Because the 2.5 and 2.6 are focused on some things. 2.5 is closer to pre-algebra, but in 2.6 it is pre-algebra, but it's also taught in an algebra classroom. So please, if you ever have to go to the next section before you come back, that is completely fine. But it's just important that you note that the order in which you do these does not matter for some of the sections. So that's why you should email your coach if you're not sure. Always feel free to email. So we've seen, again, if you need to move to the next section and it doesn't apply, then you can do that. But please feel free to email any concerns, questions, or comments you have. You can just say, excuse me, please can I do 2.6 after this section, or I need more examples, for example, and we'll send you more videos explaining the concept. The key thing is that you should have a good notebook where you're taking notes of each of the concepts that you're learning, because you can always go back and review. So sometimes your assignment might end up just being showing us the notes you've taken from that section, and then you move on to the next section. Of course, if there's ever a topic that we know is fundamentally going to determine if you understand the next section, then we will make sure that you get that first topic. Because math, again, is like building a house. Step by step, you need a solid foundation, and then you build from there. So let's go ahead and look at a few more examples. We've looked at the first one. So if you look at example 2 in your book, they give you a problem that involves integers, and then there's parentheses and so on and so forth. So let me do a similar problem to example 2, and I'll do the same for more of these problems from this section. So let's say we have -4 minus 3, and then we have 7 minus 9. So imagine if you have a situation like this. Well, in this case, remember, parentheses comes first, right? So if you have parentheses, then you make sure that you do that first. So we have the parentheses first. So that's going to become -2. So you have -4 minus 3, and then you have a -2. So notice I only changed one thing, right? So this is our second example, example 2. So now we have -4, and we have a minus and a 3, and then a -2. Well, the multiplication, this has to be taken care of first, because that -3 times -2 must be taken care of. That becomes a positive 6. This -4 comes down. So we have -4 plus 6, and that's equal to 2. Now keep in mind that that's the same thing as saying 6 minus 4, which is also 2. So that's an example there for example 2. Step by step, take care of one thing there, bring it down, take care of this, bring it down, and then take care of the last step. One of the things that you learn is that mathematics teaches you how to reason step by step, and that's part of what's happening here. So let's go ahead and look at the next problem. Example 3. This is our third example. Example 3. So in example 3, we have a problem that gets a little more complicated because now we have exponents involved. So imagine if you have negative 3 and then into 4 minus 7 squared and then minus 4 into 3 minus 4 squared. So if you have a situation like this, we look at the ones with the squared, right? We know we need to take care of the parentheses and the exponents. So that becomes negative 3 into, we have negative 3 inside squared, and then minus 4 into negative 1 squared. This then can be taken care of right away. Negative 3 times negative 3, so that becomes a 9, positive 9, because a negative times a negative is a positive. So that becomes negative 3, and then you have a 9, and then minus, you have 4, and then negative 1 times negative 1, you have a positive 1. So that's how you get a positive 1 there. So we need to take it one step at a time. We have the negative 3 times negative 3, which was 9, and we have the negative 1 times negative 1, which is 1. So now these two can interact. So negative 3 times 9 is negative 27, and then negative 4, and then times 1 there would just be negative 4. So the answer is negative 31 to this problem. So first of all, we took care of what was in the parentheses. We got negative 3. We square that value. We're going to do that shortly. 3 minus 4, we get negative 1. Now we apply the exponents. So first we did the parentheses, then we did the exponents, and then you just be left with going from, well, then you have a multiplication, and then we go from left to right. In simplifying, you just have negative 27 minus 4. So that's how we deal with that particular type of problem. Next one here, in looking at example 4, you have a situation where division is involved. And when division is involved in these types of situations, so let's say negative 36 divided by 6 times negative 3. So notice that you have negative 36, right, divided by 6 times negative 3. So you deal with the division first, and then you can multiply. So division first, because if you're going from left to right, the division occurs first. So negative 36 divided by 6 is negative 6, and then times negative 3 would be positive 18. So we do the PEMDAS. Remember, when you get to multiplication and division, you're just going from left to right. So that is example 4. In your book, in example 5, they give you a situation now where you have a series of exponents. Just multiply, just take care of the exponent first, right? So let's look at this one, example 5. So if you have exponents, so you have negative 4, negative 3, and then let's say negative 2 cubed, you have to take care of this negative 2 cubed first, and that actually becomes negative 8. So you have negative 4 times negative 3 times negative 8. You multiply all these together, and your answer, you're going to get negative times a negative, that's positive, and then times a negative, you're going to get a negative again. So basically 4 times 3, which is 12, 12 times 8, which is 96. So it's important that you go step by step. In this case, we have negative 96. So negative 3 times negative 4 would be positive 12, and then 12 times negative 8 would be negative 96. So that's how we do that example, a similar example there from example 5. For examples 6, it's actually, I would say you're doing it for fun, okay? You're just doing it for fun, but it's really building an understanding of step-by-step procedures. So let's say you had 7 minus 2 into negative 4 divided by negative 1 minus 2. Actually, sorry, negative 1 minus, and then we're going to put the negative 2. We're going to put a negative 2 there. So negative 2 like that, and then squared. If you have a situation like this, you can take care of, again, one thing at a time, or a few things, very few things at a time. Negative 2 times negative 4 there is going to become 7 plus 8. In the denominator, we have, of course, a situation whereby you can take care of the exponent over here. So that's negative 2 times negative 2, and that's positive 4. So that's negative 1 plus, well, actually, negative 1 minus, right? the 4 is going to be inside here. So minus, and then you have 4. And so 7 plus 8 is 15. And then in the denominator, you have minus 1 minus 4. That becomes a minus 5. So that becomes negative 3 for the final answer. So let's take a step back and look at what happened. We had 7 minus 2 times a negative 4 here. So we took care of the negative 2 and negative 4 together. And that's how we got the 8. And then in the denominator, we had negative 1 minus and then negative 2 squared. Negative 2 times negative 2 is positive 4. So that's how we get that part. So negative 2 times negative 2 is positive 4. Negative 1 minus, and then that's how we get that 4 there. So 7 plus 8 is 15. And then negative 1 minus 4 will give us negative 5 in the denominator. 15 divided by negative 5 is negative 3. So that's how we get it step by step. Very important. Do your best to go step by step so that if you make a mistake, it's easy to catch what that mistake might be. Anybody can make a mistake. So let's remember it's good to go step by step. The last two examples, you have a situation of absolute value. We have a situation of absolute value for both of them. So let's just quickly look at a similar problem for example 7 and 8. In example 7, let's say we have negative and then the absolute value of 9 like that, negative 9. That just becomes a negative, and this becomes positive because the absolute value of negative 9 is positive 9. But the final answer to the problem will actually be negative 9. That's what will happen at the end. If you had a situation where it was negative and then a negative 9 like this, this will be a positive 9 because this negative times this negative is positive. But with absolute values, you have to take care of the absolute value first. That's how you get that positive 9. You apply that negative outside and you get a negative 9 at the end. Example 8, we have a situation whereby we have, let's say, negative 4 minus 3 and then absolute value of 2 minus 3. In this case, we will take care of the absolute value over here of 2 minus 3, which is we have negative 1 in the absolute value, minus 4 minus 3, and then the absolute value there. So basically, minus 4 and then minus 3. But this absolute value is going to change. It's going to become a 1. The absolute value is going to change that negative 1. So now you have negative 4 minus 3, and then the answer is negative 7. The absolute value will change the negative to a positive, but then you have to remember that sometimes there might be, like in this case, there was a negative waiting outside. So even though the negative 9 became positive, excited, I'm positive now, it had to deal with this negative that was waiting outside, which made it negative again. So just because you have an absolute value in a problem doesn't mean your answer is going to be positive at the end of the day if there are other factors involved other than the absolute value. I hope this was helpful. Again, this chapter has a lot of fun problems for you, but please, if you have any concerns, feel free to reach out. Have a wonderful day.